Hello, children. So, welcome to this class. Now, a couple of things before I start. One is I would like to apologize for the cancellation of the last class. So, what happened was, there is a to run this class, we have to set up, fair bit of technology. So, there's an iPad and there's a lot of tech stuff. And I think until you guys become engineers and you fix it, even today technology is like in a really bad shape. So the same setup which works now, after 1 hour it'll stop working. Internet will stop working. So all kinds of stuff happened. So first of all, my apologies to you, and I hope that today's session we don't face any challenges. Okay. So anyway, so thanks for joining, and would love to today. Let's continue our lessons and make sure that our understanding of some of these concepts of reflection, refraction, the sort of get better. And one thing that I want to emphasize is that learning should be fun, right? So I'll try my best to make it enjoyable. I'll ask you a lot of questions. I'll make you think, right? And I want you also to take it in that spirit. So think of it like an adventure. You are kind of discovering new things, right? So don't think of it as a boring thing. It's actually quite exciting. Right? And the concepts that you learn now, these are the things that when you look at a big Nikon camera or all those fancy equipment, they are ultimately using the same concepts that we are learning now. Obviously, there is a lot of things they do in addition, but things that we learn now, they are like very valuable. Okay, so let's get started, right? And so once again, welcome to all of you, and I apologize for the confusion last time. Hopefully, this session, coming sessions, hopefully they'll all go fine. Okay. So next question for you is, so I'm going to now switch to a different. There we go. Here we are. Right? So let me now start by a quick revision, and I'm going to ask you a couple of questions. Also, let me just welcome people who are in the class. Now I can see some names here. Maybe those are your names. Maybe you're using your dad's IDs. I'm not sure. So we have Adityan. Hi, Adityan. Gauri. There is one handle, gamer123. I don't know what your name is. Whatever. So hi to you, Kashmira P. Hi everyone. So we have a small class here, and let's get started. Right. So now let's first ask these simple questions. Again, some of these things you know. My style of teaching is I want to ask you questions. I want you to think, right? And together we'll figure things out. First question for you is, what is a spherical mirror? Right? So now take half a minute, think and tell me what is a spherical mirror. If somebody asked you like how would you explain that? Right? What is a spherical mirror? This is a question. So I would ask you to maybe if you can type in the live chat, that'll be great, right? So while you guys are sort of giving out the answer, it's a pretty straightforward thing, which is what are the two words here? So let me change the color of the. Okay, so we have the word spherical. Spherical means sphere, and mirror, right? So if you take a sphere, right? If I were to take a sphere, right, like this, and from this sphere, if I were to cut, take this out. Now this is part of a sphere, and this is therefore I can call this a spherical mirror. Okay, very simple idea. Next question: what is the radius of curvature? Oh, by the way, I didn't mention mirror. So essentially, think of it this way. Let us say I take this and now I polish it. Right? I polish it from put some silver kind of coating, so that this side is from here it is reflecting. So once it reflects, we call it a mirror. Very simple idea. Okay. Next question. What is radius of curvature? What is the principal axis and what is the pole? So what is the radius of curvature? Pretty straightforward. Right? Thought about it? Okay, so radius of curvature is nothing but, so this mirror is part of the sphere. So the sphere has a radius. Whatever is the radius, so let's say the sphere has a radius, or radius is r. So for this mirror also, we will say that its radius of curvature is r. That's it. because we don't say radius because radius is defined for a sphere. It's not a full sphere. It's like a part of a sphere, right? So we'll say instead of calling it radius, we call it a radius of curvature. That's it. Nothing more than that. Okay, next question. Quick recap. What is the principal axis? What do you think? Principal axis. So let's do that. Principal axis is again pretty straightforward. Let me do one thing. Let me first get rid of this sphere which I don't need. Okay, now it looks. There we go. There we are. Okay. So now think about this way. So let us say there is a this is the center point. Okay, what is center point called? So this point is called a pole. Okay, so the center is called a pole. Now what I'll do is, if I take a surface which is just touching this point, so this surface is tangent, right? It's a tangential surface at touching at only this single point. Then if I draw a line such that this line is perpendicular, to the tangential surface, then this is called principal axis. Right? Once again, let me just no. I will just make a small, just write it up a little nicely. Okay, so this is principal axis. There we go. Okay, now one last question which I had. What is, so we have answered 4. Okay, so this question is answered. Now next one, which is, when an object is at infinity, rays of light are parallel. Why? I have explained this in a lot of detail last time. Do you guys remember? We had a long discussion. Right? What is the discussion? So again, I'll do a quick recap. I'll not spend too much time. So let us say this is a point. Okay, let's say this is a point, and here this is your mirror, and I want to take rays coming and touching the mirror at 2 points, here and here. Right? Now if I do that, let's say if I take one ray coming from here like this, right? And if I take another ray coming, okay, this one, little bit. Okay, so actually you can't, sorry, what I'll do is, it's a little hard to draw, so I'll remove this automated drawing. I'll just draw with my free hand. Okay, we don't need this. Okay, so now if I draw a line from here, if I draw one line which goes like this, another line which goes like this, right? So the second point is not here, second point is here. Okay, now these two lines, I know it's very badly drawn, but if you look at these two lines anywhere, let's say I look up here, right? Look at these two lines. These two lines are almost parallel. So when the object is far away from the mirror, right, then the rays coming, they are parallel. This is the idea, right? Because the angle between them is going to be very, very small. This is the intuition. So when an object is at infinity, which means it's very far compared to, let's say, the focal length or the aperture and so on. Okay, I hope this is clear. What is focus and focal length? So this we have discussed. What is the focus? So very simply put, right, focus is, if you have a mirror, right, if you have, let's say, I'm taking a concave mirror. We'll talk about convex mirror also later. Let's say there's a concave mirror. Okay, and this is the principal axis. Now let us say some parallel rays are coming. This is one ray, this is, say, another ray. So all these rays, after reflection, they would all meet at a given point, right? And the point where all the parallel rays meet, okay? So point where the parallel rays meet, this point is called focus or principal focus, okay? And what is focal length? This distance, okay? This distance is focal length. Let me write a little nicely here. focal length. Okay, so this is also done. I'll just leave this here for a few seconds. If you have any question, you can please feel free to ask me. Do not hesitate. Okay. Okay, children. So now, if I get a question, I'll try to answer. Let me just go back to this. Okay. So we talked about now focus and focal length. Now, where do parallel rays meet after reflection for concave mirror and convex mirror? Now, concave mirror, the first one, right? This one is sort of not very hard to imagine. Right? So if you think about this, right? Where do they meet after reflection? So the answer is after reflection, parallel rays they meet at focus. But here is a question for you. This will, and I'll give you some time to think about it. Now I have a different mirror. I have a convex mirror. Let me try to draw this one. Okay. So let's say this is a convex mirror. Okay. By the way, when I make these lines, what does it mean? Maybe you have thought about it. Maybe you have not. So let me just give you an understanding. Okay. So okay. So one question I have from Jayan is, what is focal length? Once more, no problem. Let me explain that. So Jayan, this is for you and for rest of the class as well. Okay. I'll go very slowly. Do not hesitate. You can always ask questions. I'll be happy to explain again. Okay. Let me make this a little bigger. Okay. And also I'll write this a little nicely. This is not very cleanly written. So let me write this a little slowly. Okay. So this is your focal length. Now the question is, one student wants me to explain what is focal length again. So I'll explain again. I'll do it very slowly. Okay. Now let us say you have parallel rays coming and hitting a mirror. Okay. So there are these. Now I've drawn only two. I can draw as many as you want. So there are multiple parallel rays coming and hitting the mirror. So the question is, what will happen after they hit the mirror? And the answer is, for which I gave you the intuition last time. If you want the intuition, tell me. I can explain again. Okay, so Jayan says I was late. Okay, so the intuition behind this is, let me actually do that again. It might just be a little helpful. Okay, so let's just think about this mirror. I didn't like the shape. I'll draw it again. Hopefully, yeah, this is slightly better. Okay, now this mirror, it is from this side there is some coating done. Okay, so from this side, let us say somebody has taken, so we have taken some silver color and we have coated from this side. So this side is shining. Here this side is not reflecting. Okay, this side is the reflecting side. Now let me ask you a question. I'm not even going to give you the answer. I will ask you a question and you will have to now think about it. So here the question. Now let's say if I have a ray like this. This is a ray which is going like this. What will this ray, and this is the pole, right? What will this ray do after reflection? It goes and hits the mirror. After this, what will happen? Pretty straightforward. And the way to think about this is, children, what I would like you to do is, okay, by the way, Gauri is asking, sir, will you explain about the parallel rays when the object is infinity? Once more, please. No problem, Gauri. I don't know, Gauri is your name or is your mom's name, whatever. I'll do it, no problem. Okay. So actually, let me do that again, because this is one concept, where no book explains it properly. I'm yet to come across a book which explains this properly. So I'm happy to do it again for you. Okay. All of you pay attention and don't hesitate to ask questions. So one question is, why an object at infinity is will generate parallel rays. So here we go. Let me use this. So I am going to now, let me delete this as well. This, okay. Now just look at this mirror. Okay. Now I will take 2 points here. I'll take rays coming to 2 points. Okay. So one point is here and one point is here. Okay. Now I'm going to draw a line which is the principal axis. So the principal axis is like this. Okay, there we go. Not too bad. Okay. No, this is the pole. Sorry, my mistake. Yeah, this. Let's say this is the pole. Okay, and this point. Okay, there we go. Yeah. Now the question is. Now let's say we will take an object and we'll keep the object at different places. Okay, so I'll take this object. Let's say this is a green colored dot. Green colored dot, and from here two rays are going and they're touching this. So I'm taking two rays, one ray and second ray. Right? So Gauri and everybody, just let me know if this is okay. So Gauri, any doubt, feel free to ask me. Okay. So here is my question. Between these two rays, there is some angle. Can you see this? I mean, you have not studied the mathematics of angles, but you have some idea that there is some angle between them. Do you agree? Yeah. Okay, good. Now let us say I take this object and move it back. Okay. Very carefully. Just watch this very carefully. Okay. I move this object from there to here. Now there are two rays going. Gauri and all our students, please watch carefully and tell me. I draw one ray like this and I draw one ray like this. Now tell me one thing. If this is the angle between the two rays when the object was here. Now when the object is here, the new angle is this. Which angle is more? Think carefully and tell me. This angle, let us say, this angle I'm calling A and this angle I'm calling B. Is A greater than B or is B greater than A? I'll give you 30 seconds to answer this question. I'm going to wait. All of you have to answer. I'll give you 30 seconds. Think and tell me which angle is greater. This is a question I asked last time as well, and almost all of you gave the right answer, but I'll just remind you. A is greater. Yes, correct. Good, very good. A is greater. All of you can see that. Now think carefully and tell me, if I take B, okay, if I take B and move B from here to here, okay. So now let us say B is here. Okay? Now the rays which are going to the same 2 points, like so this point and this point, the angle between them will become smaller. Now let's say this angle is, obviously I'm not drawing it that nicely, but if you draw it properly, this angle C will be smaller, right? So A will be greater than B, which should be greater than C, correct? This, all of you can see this, right? This is the key point. So the point is, when the object is, now you'll realize that when the object is moved away, the rays which are meeting, going to the same 2 points, those rays the angle between them becomes smaller and smaller. Now let me ask you a question. If this ray goes, if this object goes very far, let's say I make it like 100 times farther, what will happen? This angle will become very close to 0. Once again, as this object goes farther and farther and farther and farther and farther and farther, the angle will become smaller and smaller, and then it will become very close to 0. Now last question, this one you should tell me, don't disappoint me. If let's say this, if there are two, if the angle between two lines, right, the angle between two lines, I'll draw using different color, the angle between two lines is 0. I won't be able to draw, let me actually, let me try something else. I'll use a different feature. So let me try this, and then I will draw a different line. Okay, I'll draw a different line. Okay, now the see, what is the angle between these two? The angle between these two is 0, because they're, why? Because they're parallel. So this is the point. I'm not making them touch, right? But if you but the angle between these two is going to be 0. If I make them touch, they will totally lie on top of each other. So there's no angle. So angle is 0. Now what do we see here? They're also parallel. So this is the point that I want you to understand. Angle between lines is equal to 0, and therefore they are parallel. Wow, Interesting, isn't it? Yeah? See? So when the angle between them is 0, they become parallel. Now let's go back and look at this, right? So point we made was when this object is very far, the angle between them will become 0. So these two will become, they'll become parallel. That is why when the object is very far, the rays coming from the object, they are parallel. Okay? This is a very important concept, and as I said, it's never explained properly. So I wanted to make sure that you guys understand this. Any doubts, anything you can ask me. I have one more question earlier, which I'm going to address, which is from Binu. It was why silver is used on reflecting. Why is, and one more question, why always a mirror is coated? So I'm going to answer both the questions after this. So I'll give you 30 seconds. Think. If you have any questions, you can ask me. Gauri, tell me if this was clear. Okay, excellent. Now let's talk about why do we have to put silver coating, or why okay, so now the question is, let's take one more question which you guys asked, which was why do we put silver? So let's say, okay, think about it. Now let's say I just have a now assume that this is made of glass. This is like, the glass that specs are made of. Now if some light is coming like this, what will happen? What will happen if some light ray is going like this? What will happen? It will just pass through this. Right? It is not going to get reflected. Right? So for that we need this to be a reflecting surface. Now the question is, how do you make something reflect? So there are certain chemicals or certain elements or certain molecules which reflect very well. So metals are very good reflectors. You can see steel reflects, aluminum gold reflects very well, silver reflects very well. So all these are reflecting surfaces, but out of these silver is very good at reflection. That is why we call it, we put a silver this thing. Okay. So we need this light to get reflected. So I need to put something which will reflect that, and that is why we put silver or something like silver, right? Something which will reflect, and we can put it only on one. We put it on one side. Right? So if you put a silver which is very smooth, then both sides can reflect. But normally what happens is, after we put, so let's say, let me explain this to you. What happens is, when I put, let us say I put a coating of silver here. I'm using a blue color to show. Right? I put a coating of silver here behind this. Now I don't want this coating to get removed. So what I will do is, normally after putting this, I am going to put some other paint on top of it once again. So this middle layer, this blue one, is silver, and then I'll put some paint so that this is not removed easily. That is why I would actually ask you to do this. When you have a mirror at your house or something, small mirror, please take it and flip it and see on the other side, you'll see some orange or some coating like that. So that is the coating that they have put to make sure that the silvering stays there. Okay. So I hope this is clear, and let me know, and we'll now move to our other questions. Okay. Okay. So what about now? What happens? Here's a question for you guys. What happens to parallel rays after they hit a convex mirror? Concave, we said they come and meet at the focus. What happens for convex mirror? This is what I want you to think and tell me. And by the way, if it's not clear, if this concept, remember I said that here. I said that when rays go, when parallel rays go, they come and meet the focus. If this is not clear, let me explain. I think some of you said that this was not clear. Let me quickly explain that also. Okay. It's again very intuitive, very easy to understand. So don't worry, I will explain to you very nicely. Okay. So this is a mirror. Now we will take a couple of rays. So let's say this is first ray. This ray goes and hits the pole. What will happen? This ray will go like this. It will come back in the same direction. Okay. because at this point the angle of incidence is 0. If you just look at this mirror very closely, it's almost, this portion is almost flat, and this is falling at 90 degrees. So this angle is 90 degrees. If you just look at this very closely, I'm not drawing the tangent and all that, but you can do that. But here's my question: when a ray goes like this, what will happen? Will after reflection, will it come back like this? No. Why? Of course it won't come back. Why? Because this is, if you look at this surface here, right? If you look at this surface here, there is, sorry, let me use different color. So the tangent is going to be something like this. Right? So which means there'll be, so when something falls on this thing, then this red light will, sorry, this ray will probably come like this. Okay, I'm drawing it crudely, but makes sense, right? So in fact, the way to think about this is, let's say if you throw a ball, right? If you throw a ball and ball hits a wall which is shaped like this, what will happen to this ball? This ball, after hitting this, it will come here. Similarly, I can draw another ray here, and this ray also, I'm not proving it to you, but I'm just telling you, in class 11 we'll prove and show it to you. All these rays, any ray that I take, if I take this ray, I take one more ray, I take one more ray here, right? All these rays after reflection, they will come and meet at the same point. This I'm not proving, I'm just telling you. Okay, so we took 4 rays, and all of them after reflection, they came and met at the same point. Now if all the rays come to same point, what would you say? You say that they are getting focused. What is the word? See, your parents will tell you, oh, focus on your book. What does it mean? Which means all your attention has to go to just one point, which is your book, right? That is the word focus means that. So here also we can say that all the rays are getting focused. Now if they're getting focused at a point, what should you call the point? Naturally, good name is focus, right? That is why we call this point focus. Remember, when I'll repeat this, it's not that every kind of ray, only when parallel rays, I repeat, only when you have parallel rays, which are, and these are all parallel to the principal axis. This is the principal axis, these are all parallel to that. In that case, the rays will come and meet at the principal focus. I will wait for 30 seconds or 45 seconds. I want to make sure that you guys have fully understood. If not, you can ask questions. So I'll just wait. And meanwhile, I'll write this here, so that way you can take notes if you want. When rays parallel to the principal axis are reflected from a concave mirror, they meet at the focus. Okay. Now, always one thing I'll remind you: never ever take the notes by copying. Don't ever copy from the screen directly. Don't look at it and copy word by word. Okay, that's not allowed. Read it, understand, take your time. Okay, and then you write it down in your own words. I'll give you some time. Okay, I want you to think, understand this diagram, understand it fully, and then draw it. After understanding, please do not, I repeat, please do not copy it from the screen. Understand and then do it. Okay, I'll give you time. Meanwhile, let's see. Sabu, I'm Joseph. Hi Joseph, how are you? Good to see you here. Let me take some other questions. Saksham, is all the rays get focused on the incident ray which has the angle of 90 degree? I did not fully understand that question. So maybe if you could explain a little better, I can try to. Is all the rays? Saksham, I'm not, if that's your name, I'm assuming it's not your dad's name or something, but if it's your name, hi, I did not fully understand your question. Which has the angle of 90 degree? Maybe I don't know, probably you meant, I don't know if you were talking about this ray. So this ray goes, this is at 90 degree with the tangent here. Maybe this is a question, I'm not very sure. Okay. Any other questions? Okay, so I think that's pretty much it. And please please understand and take it down, write it down. Remember, think and write. Never ever copy from the board. In fact, I really want, I wish in school we did not make children copy notes from the board. It's a really bad practice. It's better to give them time so you can think and understand and then write. I'll give you the time. No rush at all. So these are things that once you understand, they will stay in your head forever. And then learning is interesting. Otherwise, it's just boring. It's just copying stuff and trying to mug it up. That's not fun anymore. How's your lockdown going on? Are you guys getting to, do you go out for a walk or something? Probably that's not allowed, right? So you have to stay in the house. Let me know if there's any way we can help. I can help. I would be happy to. I'm sure you're having fun watching movies, doing stuff, but uh, don't like spend. Do a good balance. You should have fun also. I think that is also very important. Have fun at the same time. Do painting, drawing, music. All those kind of things which are. You should. This is a good time to try out new things. So don't just sit and watch YouTube videos the whole day. Image were formed. So image is formed at focus. Okay, image is formed at focus. Okay, everybody has taken notes. Thank you. So now let's now the next question. This was one part of it. Next question, which is, remember what happens in a convex mirror? We just discussed concave. So what happens in a convex mirror? Think about it. I'll also help you, but I want you to think. Behind the mirror, not even allowed to walk outside. Yeah, I know. I know. I know. I wish children could go out and play cricket and football and all that. But yeah, hopefully when the problem is sorted, then you'll get time to play. Okay, so now let's draw a convex mirror. I'm deliberately teaching slowly, not going very fast, so you don't feel the pressure. Right? So now let's draw a convex mirror. Right? So it's opposite of concave. So this would be your convex mirror. Okay, and this side is coated, and this side is reflecting surface. Okay, from here light comes, it will get reflected. Now I'm going to draw a couple of rays, and I will ask you to think and tell me. So this is let's say the pole, and I will draw one line which will be like this. Okay, so this is one ray, right? Let's draw a few more. Okay, I'll draw one here, and we'll draw one here. Let's draw only three for now. Okay, and what I'm going to do is I'm going to sorry, make it a slight. Okay, so now the question is, 1 second, I wanted to compress this slightly. What happened? Okay, I'm trying to zoom it a little bit. This is a little problematic. Yeah. Okay, now let's this should be enough. Now, let's see. No, this reset. Okay. So now the question is, what will happen to these rays? Now we will use basic common sense. I'm not going to ask you to remember any formulas. Forget all formulas. Okay, let's just use very, very basic common sense. My question to you is very simple. Let us say you are throwing balls. Okay. Now these are three balls which are going and hitting a wall. So in your mind, think about this. This is a wall. Okay. This is a wall. You throw one ball like this. What will happen to this ball? It will come back, right? You throw one ball like this, circular ball. What will happen to the ball? What do you think? Will it come back? No. Why? Because there's some angle here, right? So if I were to draw, if I draw a tangent here, a tangent would be something like this, right? And there is some angle here. So what will happen to this? So this ray, if this was a ball, the ball would get reflected like this. So this angle is going to be equal to this angle. So this is where your ball would go, correct? Now if you did this, if you took this ray, what will happen? This also will get reflected something like this. Very, very simple idea, right? So now you can see there are three rays. This is the first ray, right? The second, the third ray. What's happening? These three rays are going. Earlier the rays were converging, right? They were all coming to the same point. Now they are moving away as if they don't like each other, right? So as you can see, these rays are moving away from each other. We call them, they are diverging. Okay, so they are diverging. Okay, they are diverging after reflection. But here's a very interesting thing, right? If I were to project them back, if I were to project them back, so let us say if I extend this, if I project them back, what happens? They are all going to again meet at the same point. Now remember, okay, let me actually do this. Let me use dotted lines for this. So I will use dotted lines. Dot, 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 because this is not a real ray, right? I'm just extending it like this. So as we can see, all the rays, they are when they are extended back, they're meeting at this point. And here for a convex mirror, this point is called focus. Okay, this is called focus. So here what happens is the rays diverge, but geometrically, okay, geometrically even when diverging, if we extend them back, they'll all meet at the same point, and this point is called focus. And this focus is, or sometimes we say focus, or we can also say principal focus. Okay, focus, or we can also say principal focus. Okay, now why principal focus? Later on you will see that there are two focuses. Actually, foci is the word, but I'll just two focuses. So when we talk about lenses and all that, so you'll see the word principal focus, but for now focus is also enough. Okay, so here's a question, Ashok sir, can ray reflect in same direction? How is it? Because it is at the middle, right? So here if I were to draw a tangent, the tangent would be like this. So this is making 90 degree with the tangent. So it's like you throw a ball at a straight wall. What will happen? It will come back to you. That's the idea. Okay, virtual image is formed. Very good, excellent. So here in case of a concave mirror, right, the rays met here. In case of a convex mirror, the rays are not actually meeting. They are meeting when we extend them back. So here we will say that the image is formed at the focus. Here also we'll say that image is formed at the focus because the rays are meeting. So now let's talk about image formation. Okay, and this is a very important concept. Okay, and this is very, very important, and I'll take the time to explain to you, because I'll tell you one thing. Even if you ask a lot of your class 11th and 12th seniors, maybe your brothers, sisters, anybody who I can assure you, 80-90% of students, they have finished class 11th, and they have, some of them even got into IIT or got into engineering colleges. Even they don't know what is the meaning of the word image. When you say image is formed here, what does it mean? Very few students understand. So I would like to explain that to you today. Okay, shall I do that? Good, let's do that. So now images, let's see. So what is image formation? Image is, let me first give you, I'll give you the intuition behind this. Let us say there is an object here. There is a green colored object here. Okay, this object is sending lot of rays like this. Now, if let us say, think, just use your intuition, common sense. No need for any advanced thing, magic, nothing, advanced science, nothing. Very simple idea. This is a green object. Let's say it's a LED, green LED. It is sending out all these rays here. Now, let us say if there was a white screen here. Okay, there's a white screen here. What would you see here? You would see a big patch which will be very light green. It will not be. This is very bright. Okay, this is very bright. Here you'll see it will be like very dull, but it will be spread out. Why? Because the light from here it's spread out. Makes sense, right? Okay, cool. Now very carefully. Okay, now let's say you did not have. There was no screen or anything. But let's say we found some mechanism. Don't worry about how it happens. We'll explain that later. Let's say I put a lens or something here. Okay. Don't worry about how lens works. That is not important. The point I'm making is, if I put lens or something and such that, let us say, all these rays will come and meet here. Just use your intuition. Tell me, all these multiple rays, many rays they left from here. Now, because of something I did, maybe I put a lens, whatever, I did some magic, doesn't matter. All these rays are again meeting. My question to you is, if this point was a green dot, what would this point look like? It would look like a bright green dot, right? Which means this point looks like this point. Now, if let us say you had, let's say, some painting here or some drawing here, and it had different points or different colors. Now this point looks like this point. This point, which is here, right, corresponding to this point, there is another point here. So essentially, what I can do is all the points here corresponding to those points, there will be the points here which look exactly, these points look exactly like the points here, which means if there is an image here, you will see the same image here. Makes sense, right? This is exactly what I showed you. This is exactly what a camera does. Camera works exactly. I'm giving a very basic idea. Just the intuition, then I'll give you the core definition. Okay, this is how a camera works. So essentially what we see is, in here we see that when multiple rays after reflection, but in general it could be reflection, so this is refraction, but it could be after reflection, doesn't matter. If all the rays after reflection or refraction, wherever they meet, that point is called the image. Once again, the rays after reflection or refraction, wherever they meet, that point is called the image. And this is so important that I am going to write it down so you will never forget. Okay, and I'll explain to you a little bit more. Okay, image. Let me actually do this. I'll write for the question: where is an image formed after reflection or refraction? You learn about refraction later, but I think it's important to understand image formation first. So this is a question. Okay. By the way, it's almost 7:15. So after this explanation, I'll give you a short 5 minutes break, so you can maybe have a glass of water, relax a little bit, and then we'll start. Okay. So before the break, let me explain this. So where is an image formed? Where is an image formed after reflection or refraction? So the answer to this is image. An image is formed wherever, write a little nicely. Please don't copy from this. I would just wait and just first understand this, then I'll give you time to write. Okay, image is formed at a point where the rays meet after reflection or refraction. Okay, I have not talked about virtual real. We'll come to that later. First, this is the idea. Okay, an image is formed at a point. Image is formed at a point where the rays meet after reflection or refraction. Okay, this is the basic idea of an image. Now let me bring in the real and virtual, and I'll also explain that. Then I'll give you a short break. Okay, don't worry about it. When the rays actually meet, okay, so here in this case, right, all these rays, they came and they actually met, right, they actually meet here, right? Can you see that? I'll just remove these. Okay, now if we look at this also, here also, all these rays, this comes and meets here, this comes and meets here, this comes and meets here, right? So all these rays are actually meeting here, correct? Now I'll clean this up. Okay, so when the rays are actually meeting after reflection refraction, we call it a real image. Okay, so now we'll say real image. What is a real image? When the rays actually meet after reflection, reflection or refraction. Now this is real image. What is virtual image? Virtual image is when they are not actually meeting, but they meet when you extend them back. So here you can see this ray goes like this goes like this goes like, so they're all diverging, right? They're moving away from each other. But if you extend them back, then they meet here. Okay, so now we'll talk about virtual image. Okay, virtual image. When rays meet after only when extended backward. So these are the two definitions. One is real image, second is virtual image. Real image, the rays actually meet, right? And virtual image is when they meet only when extended backward. Right? This is the difference between the real and the virtual image. And I'm going to now ask you, I've taught you actually quite a few, well, not covered a lot of new stuff, but we've done a lot of revision of the important topics. So this converging, diverging, and this one, right? I want you to take notes carefully. Don't copy from the screen. Please take your time. Okay, you want 2 minutes, 3 minutes, 5 minutes, whatever time you want. You take your time, write it down. And right now it's almost 7:18. I'm going to give you about 5 minutes, 5-6 minutes break. So just after this, go and have a cup of water. You can have coffee. You can maybe go and jump around, play with your dog, or whatever, have fun, and I'll come back in 5 minutes, 5-6 minutes, then we'll start. Okay, and meanwhile, if you have any questions, you can always ask. Enjoy the break. Okay, one question I have is it right that in concave mirror, image is formed at the focus? So tell me, when will image be formed at the focus? Remember, we had like discussed that image is formed at the focus when the rays of light, they are parallel. They are parallel to the principal axis. When are the rays of light parallel? When the object is at infinity, which means object is very, very far, right? Compared to the focal length and the aperture, etc. The distance compared to the focal length, if it's very, very much higher, in that case, we can say that the rays of light are almost parallel, and then and only then the rays will converge at focal lengths. In fact, when you have a concave mirror, if you when you know if you let the light of sun come, in fact, I have done videos, I have done experiments where all that is, we can see all that. We can see that the rays will sun rays will converge at a point, and that is the focus of the mirror. When you see the experiments, it'll make a lot more sense. Okay, one question from Gauri is, in real and virtual image, will the distance between object and image be the same? No, Gauri, it will not be the same. In fact, we'll be spending a lot of time discussing and understanding that. So you'll be able to understand that very well, very clearly. In fact, it's a very good question. Um, there are so image and object distance, they have a relationship, and what is the relationship? All those things we'll be discussing. We'll be solving a bunch of problems as well. Okay, but it's not the same. This is a break time, so you can go and enjoy the break. Come back in another 3 4 minutes, 3 minutes maybe. Okay, so one question Gauri has asked is, will you give the correct definition of image? So Gauri, image is the point where, like I said here, um, where the rays meet after reflection or refraction. That is that point where they meet. That is what we call it the image. See, let us say I'm let's say um, I'm a painter or a sketcher, and I'm doing your sketch. So I'm doing your portrait. Okay, so you're sitting in front of me, and I'm painting. I'm sketching you. Right? So they will say that the sketch is good when, so now this looks exactly like you, which means all the in your face, hair, whatever, all the features, they are reproduced exactly. Right? So essentially, in a camera, what happens? Same thing happens. So from all the points of my face, or whichever picture is being, whatever is the image in front of the camera, all the light coming from there, it converges at a point inside the camera. That is how the image is produced. So essentially, images where all the rays of light from a point, they meet at a point, that point is called the image. Okay. Let me know, Gauri, if this is clear. If it's not, I can explain. So one question is, how do you spend your lockdown? So what I do is, I I get up in the morning. I get up in the morning at around 4:40, and then I run a program. I don't know if it's probably a little difficult for children, but I run a program where we are helping children, helping actually everyone, not just children, anyone, people to build healthy habits. So 5 o'clock, I do a YouTube session every day where uh, sharp 5 a.m. Okay, 5 o'clock in the morning, I do a YouTube live session like exactly like this, where a couple of us, I and other people, we come online and we discuss, we talk about the day, and we have a morning routine, which is we do meditation, and after that we do some physical workout. So that is what takes good amount of time in the morning. After that, during the day, I just, like you, your parents, everyone, I just work from home, waiting for the lockdown to get over. Let's hope it happens soon. When you're back from break, please message me. Now it's time to get started. So are all of you back? Did you have your water and or tea or whatever? Let me know when we can start. Okay, so I think you guys are getting back. So we will now start. Let me switch to my camera. Okay, so now you had a nice short break. You had your hopefully had your tea, coffee, water, whatever. Now shall we start? Okay, so let's move to the next question. And we have how much time? We have about half an hour. It's not that much time. So let's try to cover some interesting stuff. Let's do that. Okay. Now, just to recap, I'll go back to the. By the way, we have not covered new stuff. We've done just only revision, but that's fine. It's important because these things, once you understand well, you will hopefully not require to read the same thing over and over again. Okay, so where do parallel rays meet after reflection? So after concave mirror, they meet at focus. After in convex mirror, what happens? They don't meet, they diverge, right? They don't converge, they diverge. But when extended back, they meet from focus, which means after reflection, they move as if they are emerging, they're coming from the focus. That's what the rays will look like. Okay, now we are going to now the question for you is, what is the relationship between focal length and radius of curvature? Okay, focal length and radius of curvature. What is the relationship? First question, is there a relationship? Very, very carefully, take your time, no rush. Okay. Is there a relationship? Now I'll start explaining to you. Okay. And I will not give you the answer. I would like you to think about it. So let's take two let's take two different concave mirrors, one with a small radius of curvature, one with a large radius of curvature. Okay, let's do that. So here I will take I will so no, it didn't come out well. Okay, I want to draw sphere. Yeah, this one is a nice one. Okay, shape match. So this is a sphere. Now I'm going to take a portion of it. So this is our, and I'm going to take this and okay. Now let me get rid of this big one. We don't actually, let me not delete it. I'll just keep it on the side here. Sorry. So let this be here. Now we are going to make a small, we'll make a small sphere. Okay, I'll make a small sphere like this. Okay, and now we will take a small part of it out. Now here's a question: which of them, which one will have? Now this one has got radius of curvature, so the center is here. Actually, what this one second one I'll make it even smaller just to make it easier for you to understand. We will make it very small. The circle, the sphere rather. Okay. Now okay. Now these are the two mirrors. Okay. This is okay. This is the first concave mirror. This is the second concave mirror. Okay, now here's a question. Which of them, I will actually draw a principal axis here. So this is going to be the principal axis. And here again, this would be the principal axis. Now the question for you is, which has a higher focal length? So here we know that if you look at the radius of curvature, this radius of curvature is R1 and this radius of curvature is this radius is R2. And this, whatever is the radius, the same thing will become the radius of curvature. So this radius of curvature is going to be same distance. So this is going to be roughly here. Right? So this is going to be R1 and here this is going to be R2. Makes sense, right? Now, which one will have higher focus or higher focal length? How do we think about it? We'll just use plain logic. Let's take a parallel ray coming here. So a ray which comes like this, a ray which comes like this. Here what will happen? It will get reflected, but then remember here this one has a very sharp curvature. Okay, this has got slightly flat curvature. So here what happens? This is not exactly plane, but the bend is not that much. So this will this particular ray, it will get reflected, but it will go maybe somewhere here. Whereas here, if I take a ray like this, what will happen? Here the curvature is much higher, right? So this ray after reflection, what will happen? It will bend more, right? This is the key thing, right? So this particular ray is going to get reflected like this. Its curvature is much higher, so it's going to bend more, or rather, it's going to go. This is going to go a little farther away. This is going to meet the principal axis very close to the pole. So, which means as we increase the curvature, the rays will be meeting the principal axis closer to the pole, which means the focal length. This is the focal length, right? The focal length becomes less. So this is the observation, which is that when radius of curvature, right, curvature. Okay, when radius of curvature goes up, then focal length also goes up. I can give you the formula, but before that, I want you to get the intuition. Okay, this is the intuition which you will not find. No book is going to explain it this way, right? But it's very important to first understand. Now that we know this, I am going to give you the formula. Now I cannot derive it for class 10th. I can derive it for you guys next year. Okay, but for now, I'll just tell you there is a relationship. So let's say if f is focal length, and r is the radius of curvature. The formula is focal length is equal to radius of curvature by 2. The proof is not for this year, proof will be next year. This is a very, very important, very interesting, very important, and very simple concept, right? The focal length is equal to half of radius of curvature. Okay. So now I'll give you 30 seconds. Please understand this and in your notebook draw it and write it down in your own words. Please do not copy from the screen. Okay. Look at it. Take your time. If you want more time, I'll give you more time. But think, understand, and only then you write. Okay. So now you guys have noted it down. So I'm hoping this was clear. Now I'm going to give you some questions. Okay. So let me think about it. I'll make some simple questions for you. Okay, here is a question. Think simple question, but I'll just make you think a little bit. There is a sphere, okay, whose diameter, oops, this is the center, and its diameter, let us say, is capital D. What we do is we take a we create a concave mirror from this, right? And so this is the concave mirror, and when an object is kept at infinity, right, when there's an object which is at infinity, object is at very, very far, okay, it's infinity, but which means it's very, very far, which means that the rays of light from here are going to be parallel. Okay, object is not, by the way, don't think the object is here. Object is not. Object is very, very far off. In fact, let me actually remove this so it will not create confusion. So object is at infinity. Now what happens is after reflection, okay, after reflection, all these rays, this distance is equal to 30 centimeters. The question is for you, D equals how much? Think about it, give me the answer, and then we will go to the next question. D is equal to how much? D is equal to 120. Okay. 120 what units? Millimeters, centimeters? Okay. Molly is asking, is it 120? The answer is yes, it is 120. 120 centimeters. Excellent. So how do we get that? Very simple. Like we said, F is equal to R by 2, right? Which means that this implies that R is equal to 2F. Right? Now, oops, I've used different, let me use capital F for consistency. Okay. Now, here we can see that if the parallel rays are meeting at a particular point, then this point has got to be the focus. Okay. And this distance is the focal length. So, focal length is equal to 30. So, R is going to be equal to, R is equal to 2 into 30, which is equal to 60 centimeters. And D is equal to 2R. Right? So, therefore, this will be equal to 2 into 60, which is equal to 120 centimeters. Fantastic. Very nice. If there's any question about this, you can ask me. Okay. Next one is going to be slightly difficult. So let's now do the next one. Okay. Now here, I'm going to choose a mirror. So let's draw a circle. Okay. And I'm going to okay, so now okay, this is deleted. Now this is a convex mirror. Okay, this is a convex mirror. Now let me draw the principal axis. This is the pole and this is the say principal axis. Right? Now this for this convex mirror, let's say the radius of curvature is radius of curvature R is equal to, let us say, 100 centimeters. Right? And now say parallel rays of light are coming. Like, oops, let me draw it nicely. Okay, so there are these, I'm taking 3 parallel rays, and what will happen after reflection? They will, you will get reflect. This one will go like this one will just come back, and this one will go like this. Right? Now these rays, if you extend them backward, right, they will meet at some point. Right? I'm going to call this point, let's say, A, and this point I'm going to call P. Right? The question is, PA distance is equal to how much? I'll give you 45 seconds or 30 seconds. Think about it and give me the answer. Give me a good answer. Okay? Think about it. So it seems like some of you have understood. Yeah. So question is, have all of you understood? Let me just wait for all the answers to come in. Very good, very good, very good, very good, 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 excellent. Answer is 50 centimeters, same idea, right? Same idea, which is that the focal length, okay, focal length is equal to, let me just write this nicely, okay, focal length is equal to r by 2, and here focal length is going to be equal to 100 by 2, which is equal to 50 centimeters, and the definition of parallel rays after reflection, wherever they meet or they appear to meet when extended backward, that is the focus. So A is your focus. Okay, so A is your focus, and this is your focal length. This is focal length. Good. Okay, so I hope you guys are enjoying, not getting bored, right? I hope not. Let me know. Good. So we are done with some basic concepts. I hope you have also written it down in your notebook. Okay. So image. What does image formation by a spherical mirror mean? So we have discussed this. Image formation is where the rays either meet or they appear to meet. So this I will skip. I will not. We've already discussed this. Characteristics of image formed by spherical mirror. Okay. Real versus virtual. So I will not tell you. I want you to tell me. Real versus virtual. What is a real image? What's a virtual image? All of you, type the answer in the chat box. I want to hear from you. Write down what is the real image and what is the virtual image. What is a real image and what's a virtual image? And I'm going to ask you a very interesting question, which I don't know whether you have thought about it or not. See, real image sort of makes sense, right? Because okay, it's like in a camera, you can the image is formed on a screen. But when you say virtual image, what does that mean? Right? Like, it's diverging, so it's not really an image. So why do we call it an image? Have you thought about it? It's an interesting question, right? I mean, when it's a real image, we are saying that yeah, okay, they are the rays are meeting, so yeah, that makes sense. There's an image, but why do we call a virtual image the virtual? What is the intuition behind it? Is it really an image? If it's diverging, the rays are going away, then why would we call it an image? Okay, so real image is formed when the rays actually meet. Okay, very good. Real is formed after reflection, refraction. Okay, so all of you have given sort of the right answer, but the wordings are different. Some of you have. I'll explain that in detail. Was when the rays meet only after extended back. Very good. And Mary Joes, very good. Very good. When does actually meet after? Yes, very good. Okay, good. So now here is the intuition. Okay, and this is very very interesting, which I don't think again. No, textbooks it's never explained. I did not understand when I was in class 10 or even in 11, right? So I hope to help you understand at least. Now I am going to take this image and clean this up a little bit. Okay, I'll make a copy of this. Okay, I'll make a duplicate and okay. Now what I'm going to do is I'm going to delete bunch of the stuff so I can clean up this image a little bit. No, this is totally gone, so I don't want to do that. I want to, what we'll do is we will you just clean this up a little bit so you can. Okay, now just look at this and think about it, right? Now we are saying that, and uh, this is this is something which I can assure you, like, you will not find this in other books. So therefore, I'll take some time. So please make sure that you understand this so that you don't miss it. Okay, I'll go slowly. Now here we are. What are we saying? Where is the image formed? We are saying that this is where the image is formed. This is where the image is formed. Now, why and what is the image real or virtual? It is virtual. It is a virtual image. Why is it virtual? Because the rays are actually diverging, right? They are actually moving away from each other. They are not converging, right? So we have to extend them back to get the image. That is why we call it a virtual image. But I'm going to give you the intuition behind why we call it a virtual image. Now think about it. If let us say this object was here, okay? This object was here. So I'm going to just draw the object here. Now, if you're, let's say you are watching here, this is your eye. This is a big eye. Okay, this is an eye. I'll make it even bigger. Okay. See, think of it. This is a magnified image. Okay. So we are the distances. So let's say this is an eye. Now this eye is seeing these rays come towards the eye. Makes sense, right? So this is, the eye does not know where the object is. I can only see that, okay, this row, this ray, these three rays are coming in, meeting the eye, and the eye will look at this and say, oh, they are coming from this point, so this is where the object is. But now let us say the object was actually here. Okay, this object was actually here, and there was an eye here. There was an eye here. What would the object do? Object would send rays. What kind of rays? The rays would come like this, right? Yeah, multiple rays, many rays would come, but they would come like now. I know these two eyes are different shape, size, and all that, but ignore that. Assume they're, I didn't have space, right? Assume they're the same eyes here, right? Now this eye, when it sees this ray of light coming, what will this eye say? Will say the object is here. What will this eye say? This eye will say exactly the same thing. So for this eye, the object is here, right? But this is not the object. Object is positive infinity, which means this is the image. That is why we say that when the rays are diverging, it look like they are coming from this point, and this is where the object is. It look like the object is here, but the object is not here. Therefore, this is the image. That is why we say that it's a virtual image. And virtual image can be seen by an eye. Real image, you can put a screen, right? But virtual image, even though you can't put a screen, if the light falls on an eye, I can see a virtual image. This is a very, very important concept. Please explain. Please confirm to me. I'll give you 30 seconds, 45 seconds. Please confirm that this is clear to you. Okay, I think your phones are dying, switched off, and ions plug. Okay, then we'll do one thing. I will not teach anything more. Okay, I will sort of end the class here because your phone is getting discharged and all that. But make sure this concept is clear. Let's wait for a few minutes. Okay, there's one thing. Okay, Himalayan shepherd. I'm going to talk about. By the way, after this, I will talk about other non-study stuff as well. Okay, studies are over. We'll have some fun discussion after this. But tell me, this is clear or not? The idea of virtual image. Make sure this is clear, because I will not explain this in the next lecture again. This was the last time I'm doing it. Good. Anne Marie has confirmed that she has understood. Everybody else also? Good. Okay, here's one question. There's somebody's YouTube handle is the Himalayan Shepherd. I don't know what your name is. So you're saying I am totally lost my focus these days. Can I know your name? Are you in class 10? Can you please confirm? Himalayan Shepherd handle. Are you said you are lost your focus. So here's the thing, it's not just your problem. It is a universal problem nowadays because of these smartphones. Not just for you, for me, for everyone, right? It is it is very difficult to focus, right? Um, Meena Anil says, "Sir, once more, please." Okay, let me explain this again. I'll do it very quickly for you. Um, See, let's understand this. Oops. See, here I'm saying if let's say the object was at infinity, then the rays would be parallel, and after reflection they would come like this. I'm saying when you put an eye here, what will this eye say? This eye will say that, oh, by the way, this the object from which the light is coming, right? That object is here. How do you know that? Because take a different scenario. Okay, in this scenario, let's say the eye is here and there is an actual object. What will the object do? Object will send light rays like this. But here also these light rays, as far as this eye is concerned, these light rays, 1, 2, and 3. 1, okay, I'll draw them in green so you can see this. This ray, 1, this ray 2, and this ray 3. Right? These 3 rays are going towards the eye, and these 3 rays, they look exactly like these 3 rays. There's no difference, right? So what will this eye say? This eye will say the object is here, right? So this eye will say, oh, the object is here, but the object is not here, so this has to be the image. This is the basic idea. Okay. Okay, cool. So that's about it. So today, no more learning. So what? Ask me some other fun questions, guys. What are you doing? What else are you studying? Are you spending your time watching videos or movies, or what are you doing? Are you also doing some other stuff? Are you doing any music or painting, or are you helping your parents, your mom with cooking? Are you doing those things or not? A lot of you are from Kerala. Very good. I am also in I am also in Kerala. I live in Trivandrum. Okay, Gauri from Alan Feldman. Good, good, good. Okay, Anant Ajay. I am from Kerala but living in Tamil Nadu. Where in Tamil Nadu? Okay, Jan is Kodungalur. PUBG. Oh, yo, don't do PUBG too much, please. Huh? Do do activities, do things where you are doing something. Right? Where you're doing some act. Don't just sit and watch things like paint, draw, play, run around. Right? I live in Trivandrum in a place called Jagadi. Jagadi is like near between Vardakad and Pujapura. I spend my time. Yeah, I sometimes teach children like you, and then I have work. Na? We are there's a lot of work, so we do that. Okay, guys. So children. So thank you all for joining, and I hope you had a good time. I hope you enjoyed the class. Before the class ends, please give us your feedback, how you found it, how was it useful, and so on. And soon next class we'll take it from there. Okay. Good to see that you guys are doing bottle art and singing, and craft. Good. Keep it up. Good job. Thanks very much, and give my thanks to your parents as well. And enjoy, stay safe, stay at home, and I'll see you soon. Thank you. And it's almost 8 o'clock, so we'll end the session soon. As always, feel free to help. Feel free to ask any questions. Our team will be in touch with you. Okay. Thanks very much. Bye. Take care. And also, by the way, all our videos, all the stuff I'm teaching in my videos, it is covered in a lot of detail. So feel free to go through that. Okay. It'll be very, very useful. Thank you. Thanks. Bye bye.